Welcome to AI Frontiers. Today we explore the human frontier of robotics by examining breakthroughs in cs.RO research from the arXiv preprint server. This episode spotlights 12 pioneering papers, highlighting advances from robust control to seamless human-robot collaboration. Discover how current research is shaping tomorrow's world as we share key innovations, compelling stories, and future directions in robotics. Imagine the moment when machines first surprise their creators, not just following instructions, but pausing, detouring, and behaving almost as a cautious human would. Early robots sometimes displayed unexpected, seemingly intuitive choices, pausing to assess their environment or taking detours to avoid obstacles. Such behaviors suggest a future where robots sense, adapt, and anticipate human needs. As research progresses, the line between programmed responses and genuine intuition blurs, bringing us ever closer to truly intuitive machine partners. The research discussed today accelerates this vision, moving robots from mere tools to genuine collaborators. Robotics is no longer confined to laboratories. It is entering our homes, streets, and hospitals. The latest research from the cs.RO category of the arXiv preprint server directly addresses the unpredictability found in real-world environments. Over this episode, we will delve into both the breakthroughs and the persistent challenges faced by robotics researchers, exploring the ambitions driving the field forward. It matters because robots are becoming partners in our daily lives, not just machines that execute commands. Prepare for insightful stories, vivid metaphors, and the central questions shaping the future of robotics. Picture robotics as a symphony orchestra, where each scientific discipline, artificial intelligence, mechanical engineering, perception, control, acts as a unique instrument. The cs.RO domain is the stage where these elements harmonize. Machine learning integrates with motors and sensors, enabling robots to sense, decide, and act. Sometimes robots operate independently, while at other times they collaborate closely with humans. The stakes are significant, ranging from disaster response and precision surgery to the management of daily household chores. This interdisciplinary approach is what drives the field forward. Unpredictability defines real-world environments. Noise, bias, and disturbances are unavoidable. Robustness and safety are therefore fundamental, much like a ship braving a storm. Niknejad and colleagues developed a control framework for autonomous vehicles that manages wild, heavy-tailed uncertainties, moving beyond assumptions of mild sensor noise. Meanwhile, Ghansah's team addressed humanoid robot locomotion on shifting terrains, enabling adaptive walking even when balance is disrupted. These innovations show that safety begins with resilience. Handling real-world messiness is essential for trustworthy robotic systems. Collaboration between humans and robots is taking center stage as robots enter shared spaces. Effective interaction requires robots to sense, interpret, and anticipate human actions, much like partners in a choreographed dance. Cs.RO and collaborators enhance mission management for maritime robots by integrating large language models within human-in-the-loop frameworks, making robot behavior both interpretable and adaptable. Mueller's work enables robots to infer human intent by reading gestures, bridging the gap between human and machine understanding. As collaboration deepens, robots must become more responsive partners. Learning-based control, efficiency, and generalization are redefining what robots can achieve. Rather than memorizing fixed actions, robots now learn underlying principles. Matsuno and colleagues introduced a deep learning control algorithm that guarantees stability even in robots with unpredictable dynamics. FAM's depth-guided reinforcement learning, or DEGUV, allows robots to focus on visually relevant aspects, improving generalization to new scenarios. ROS's flower policy delivers state-of-the-art performance with fewer computational resources, democratizing access for smaller labs. SHU's knowledge-driven diffusion policy enhances autonomous driving, offering flexible, expert-informed decisions. Recent research offers compelling stories from the front lines of robotics. Niknejad's robust control system excels at handling chaotic sensor noise, ensuring stable performance. ROS's flower policy lowers barriers to high-performance robotics, making advanced capabilities more accessible. SHU's diffusion policy leverages expert pathways, resulting in stable and explainable autonomous driving. FAM's depth masking technique bridges the gap between simulation and real-world deployment, enabling robots to focus on what truly matters. Ghansah's hierarchical control empowers humanoid robots to adapt to unfamiliar and dynamic terrains, much like toddlers learning to walk. Traditional robotic controllers often assume that sensor errors are gentle and random, but real-world environments present heavy-tailed, unpredictable noise. Niknejad and colleagues addressed this by modeling sensor noise with more realistic, heavy-tailed distributions. They employed constrained zonotopes, a mathematical tool, to capture the full spectrum of possible sensor errors. Control decisions were reformulated as a linear program, improving computational efficiency. An innovative use of slack variables prevents the controller from becoming overly conservative, ensuring that robots act decisively while maintaining safety. The technical foundation of Niknejad's approach rests on contractive invariant sets, which mathematically guarantee that the robot's state remains within safety bounds. Minkowski-Lyapunov inequalities are utilized to ensure actions are both stable and robust, even amid significant disturbances. The framework was tested on an omnidirectional robot equipped with neural network-based perception systems. Under scenarios with wild sensor disturbances, this method consistently outperformed traditional controllers. The real-world hardware results demonstrated stable and reliable control, even when sensors delivered unreliable data. Niknejad and colleagues' work marks a significant shift in robotics by discarding outdated assumptions and embracing the complexities of real-world environments. Their framework achieves a careful balance between safety, performance, and computational practicality. This research inspires new approaches to resilience, demonstrating that questioning established norms can yield safer, more trustworthy robotic systems. The project sets a new benchmark, encouraging future developments that prioritize robust operation in unpredictable conditions. Envision the field of robotics as a rapidly expanding city, with each breakthrough serving as new infrastructure, bridges, buildings, and public spaces. As robots grow more robust and adaptable, they will venture into increasingly unpredictable environments, from disaster zones to dynamic urban settings. Human-robot collaboration will deepen, with systems sensing human moods and resolving conflicts seamlessly. Advanced learning mechanisms will allow robots to switch roles and tools as situations demand. The trajectory is clear. The future will feature robots as transparent, trusted teammates. To conclude, advances in robustness, learning, and human-robot collaboration are converging, propelling robotics to new heights. The stories behind these papers reveal relentless curiosity, creative problem-solving, and a drive to bridge the gap between theory and real-world application. The overarching narrative is one of robots learning, adapting, and proactively anticipating human needs. Engage with the references, participate in the ongoing conversation, and remember that today's questions will fuel tomorrow's revolutions. This episode was synthesized using GPT 4.1 from OpenAI, with text-to-speech technology by OpenAI and supplemental images via Google. Content has been reviewed by human experts to ensure clarity and accuracy. Though some oversights may remain, references are provided for further reading. AI tools make it possible to rapidly synthesize and disseminate cutting-edge research. with the goal of making robotics advances both accessible and engaging for a broad audience. Subscribe to AI Frontiers for in-depth explorations of artificial intelligence and robotics breakthroughs. This channel offers research summaries, expert interviews, and timely updates to keep you informed. Share your questions and insights in the comments and join our growing community of AI enthusiasts. Thank you for delving into the frontiers of robotics with us. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.